how do I reliably get the application path for an app written in C#? Well, what I'm going to do is explore several different functions which return path information and show where they can be useful or where they can sometimes fall short of giving the full path. So to do all of this, I'm going to make a new console application, and we'll demonstrate a few different ways inside of here. I'm also going to turn around and immediately save this application because I'm going to need to show it being run from a folder. So I'm going to call this app simply app path.
Oh, it looks like caps got jumped on.
It does indeed. There we go. App path, we have our app saved. And I'll begin with one first quick way of getting the directory from which this app is running. We can do that using the directory.getCurrentDirectory method. And we could show that on the console by doing a console write line. And then inside of this write line, we'll look into the system.io namespace. Inside of there we have the directory class. Directory class has a method called getCurrentDirectory. If we drop that in place, and then also hold up execution after that information is shown by running a console.readline, if we were to run the application, we see we get a path returned giving our Visual Studio current path with the app path project, the app path subdirectory, our bin folder, and our debug folder. And that is indeed the folder where this executable resides, because I could bring up our projects folder. Here's our app path project. We have to go into the app path folder, inside the bin folder, then inside the debug folder, and here we find our app. And everything seems to be working just fine. But you have to be careful when using current directory, is that because current directory really is the current directory for the application, and that directory can change. Doing things like running a file open dialog can actually change the current directory of the app. As a matter of fact, we can even show another instance by running this app from within Windows. Like, let's say we invoke the app by dragging some other file on top of it. Let's say, for example, we wanted the app path executable to process a file. So we drop a file onto it, which does indeed load the application, but look at this. The path is now wrong. That's the working directory, but that's not where the application resides. If we were relying on this information to represent the application path, we would now have lots of problems. So let's look at another way that we can get the application path. I'm going to comment out this line, and we can we'll just leave these here for reference. Let me do another write line, and let's look at the application.startup path value. This value is held within the system.windows.forms namespace. Inside of windows.forms, we have the application class, which has a property called startup path. Now, at the moment, this won't actually compile because system.windows.forms is found in a separate assembly. So even though we're trying to reference that, we don't yet have access to the system.windows assembly itself. We would actually have to go over to references, add a reference, and then scroll down looking for system.windows.forms, add that assembly into our references, then we could build and run, and now it is indeed working. So here we have the startup path, and the nice thing about using this one is it is more reliable. If we run our application by dragging another file on top of it, we still have the correct application path. The drawback here was the fact that we had to go and add the system.windows.forms reference as our assembly, and that would make our application generally less cross-platform, as now we are dependent on system.windows.forms, which is a little bit inconvenient here because we were just trying to write a console application. We had no other need for system.windows.forms. So let me show one final way in which we can get a reliable application path without having to use this reference. And that's by using reflection to look at ourselves as the current assembly. So what I'm going to do here is I'll first begin by stealing the console.writeLine code just for brevity's sake.
Actually, in this particular case, how about we create a string variable, dump the information into that, turn around and use...
That's not a bad idea. Where that's going is this call is actually two different calls, and there's quite a bit of code which will cause us to have to scroll off the side of the screen here. So in order to save space on the screen, I'm going to make a variable called path. We'll just make a string variable path, and we'll gather information into path, then turn around and write that out using our console write line. That'll, again, just help us see everything, help us keep everything on screen.
Cool.
So we could take our path variable, And now let's look up where the application actually resides by using reflection. So what I'm going to do is look into the system.reflection namespace. From here we'll look at the assembly class. Inside of assembly there is a method called getExecutingAssembly. That method will of course return the executing assembly. Now we can look at that assembly, and one of its methods is getName. We'll run the getName method, and then getName will return the assembly name, and from assembly name we have a property called codebase. And that should give us the location at which this assembly resides. If we run the application, we can see that while that is indeed pointing to our current assembly, this of course being the assembly that is our app path executable, the app path is given us in URI format. That is, we begin with the file, : // and then all subsequent forward slashes are, or all, excuse me, all subsequent directory separators are forward slashes. To make this a proper Windows
to make it even
formatted,
worse, though, real quick, we also have the app at the executable mentioned at the very end
exactly.
as well.
The behavior is actually different in this case. The app path is included, so this isn't just the directory. This is actually including the path to the
That's right.
executable. So in order to mimic the behavior before, we're actually going to have to work with this a little bit. So what we'll need to do is first convert that path over into a proper Windows-style path. And we can do that. Of course, I would imagine if you're on a different operating system, whatever path type is appropriate for the local system. So in order to do that, what I'll do is I'll look into the system.io namespace. From IO, we're looking for the path class, which is going to contain a method called getDirectoryName. So we'll run getDirectoryName on this URI path, and I'm actually going to drop down to a new line just to give some more space and finish off the parenthesis for the call to getDirectoryName. If we run this using getDirectoryName, we can see that all the forward slashes have now become backslashes, and the executable name is now gone. We're looking at only the directory, so that's good. Though there's one final thing to clean up, and that is the entire string still begins with file : / now. We would need to strip this off. Now fortunately it is very easy to strip characters off the beginning of a string. We can simply use the substring method of a string. And looking at this entire return here as a string means we can go and say dot substring and then specify that we would like to strip 6 characters. The reason we're stripping 6 is because of course the word file has 4 characters in it. Then we have a colon followed by a backslash for a total of 6 characters. So now if we run, we get our application path, the full path, and now let's test and make sure that it is still as reliable by copying a file onto our executable, and even when starting in this manner we're still pointing to the correct application path. So with that, that's going to wrap up this video.